welcome. This could or could not be, may not be the second last video, okay? For 5.4, because 5.4 is really long. It's important. It's got a lot of abstract things that you may be like, what? But no worries, you're gonna practice just what you need and get exactly what you need, okay? Don't worry, okay? Work with me here, though. Part 4 of 5.4, okay? In calculus. Part 4, the second fundamental theorem of calculus. Let's read over this theorem together. The second fundamental theorem of calculus. If f is continuous on an open interval I containing a, then for every x in the interval, this is true. So let's take a look at this, okay? You're taking the derivative of this integral with respect to x. But you see how this guy and this guy, they don't agree? That's why we got to apply the second fundamental theorem of calculus. Later, we're going to learn how to deal with this situation in 5.5 when we start bringing in the rules and the techniques, okay? Now, this is just basically you're taking a function with respect to t, right? You're integrating something with respect to t, and you're taking it from a to x, and then when you take the derivative of that, you actually get f of x back. That's what it's saying. So let's try to dissect this a little bit, okay? Let's go here. Definite integral as a number. Let's say you have a constant. So this will make sense later too when we practice with it, okay? Let's say we have a constant here from a to b, right? Let's say these are all constants. A's lower bound is a constant and your upper bound is a constant. That means here f of x, f is a function of x, okay? And this is what we've been doing. Okay? So nothing fancy here. So always been a constant and constant, right? Like we went from -1 to 4, right? And we took some function of respect. We took the integral of a function with respect to x. Let's go here. The definite integral as a function of f is a function of x, okay? F is a function of x. So we have f of x, right? This is the actual integral of this guy here. But you see how this guy, f, is a function of t. And a is a constant. And this x is f is a function of x. So when we integrate this, I'll demonstrate with an example how this becomes this, okay? It's because we're integrating with respect to t, but when we plug in the x and the a, the upper bound and the lower bound, it actually becomes a function of x in the end. So I know this seems a little bit odd, but let's actually try one, okay? Okay, so I'm going to show you one example that may make things a little bit clear. And I want to show you that it's not hard, okay? Okay, so I have this one here, okay? I'm going to skip the first one. Let's go to this one here. Using the second theorem of calculus. Using the second fundamental theorem of calculus. They want us to find the derivative of f of x. What does that mean, right? What does that mean? Okay? Okay, so that means f of x is equal to this, right? And notice that this is a function of t, but this is the upper bound is a function of x. Okay, so let's actually do this, okay? Let's just take the derivative or the integral the way we know how. The integral of cosine of t is going to be sine, right? Sine. Just look at your formula shit. Sine of t, and you take it from pi over 2, so you're taking it to x cubed. And when you integrate that, you'll get sine of x cubed because you're replacing the t with x cubed, and you're taking sine of pi, sorry about the ugly handwriting, pi over 2, okay? And when you do that, this is what f of x is equal to, sine of x cubed and sine of pi over 2, which is 1. So we can calculate that. So now we have this f of x. Now it's all in function with respect to x. But they want us to find the derivative, so all you do is this. You take the derivative of this guy, and you know, okay, so do you remember how you do the chain rule? Don't forget, because sine of x cubed is going to be taking the derivative of the whole thing, which is cosine x cubed, but don't forget chain rule, so 3x squared. So just like there's chain rules for derivatives, there's gonna be rules that you gotta follow for integrals later, coming soon, okay? And here, that it's just 0, so that's the answer that they're looking for, okay? For now, just know that anytime they mention second fundamental theorem of calculus, there is a function of another variable involved, okay? Okay, let's move on. Now, again, slow down the videos or stop and ask questions, okay? I want to give you some applications and some examples for what we've been talking about. For example, the average, right? Let's just do some average examples. So part 5 is just going to be applications with the second theorem of calculus, second fundamental theorem of calculus, and the average value of a function, okay? Okay, find the average value of this here from -2 to 2, okay? So what's really nice to recognize, there's a lot of things that you don't know yet. I just want to warn you, okay? So we're going to just do our best with what we know. So this guy here, isn't this really this? It's a circle from -2 to 2. It's a semicircle, actually. Okay, can you see why that's true? Just plug in some values here. You'll get this, okay? All right, so the average value was what? 1 over b minus a, right? 1 over b minus a. You take it from a to b, and you have your function, 4 minus x squared dx, right? Okay, but your I'm sorry, I didn't plug in the b minus a, right? So -2 to 2, right? Because b, a, and b. Oh, sorry, I should put +2 and -2, right? Oh, sorry, +2 because it's -a, right? Here, it's going to be -2 to 2. And here we have square root of 4 minus x squared dx. Now, I'm going to warn you here, you don't know how to integrate that. So go ahead and plug that into your calculator and see what you get. Have you done it yet? Okay, you should have got, so take it from here to here, put it in your calculator, you should have got 1/4 times. This whole thing becomes just 2 pi. Okay, okay. Think about why that's 2 pi based on this image here. Okay, and then when you do that, you get pi over 2, right? Hiya, hiya, and that's going to be about 1.57. Okay, always makes sense with the image here. Okay. Okay. All right, so I'll show you some more examples in the next video. I hope you come back. I hope you're not tired. Bye.